Hello. OpenStreetMap. Yeah, I've been mapping since 2008 in peaks and troughs, but mostly around Perth. If you look at the map of Rottnest, quite a bit of that's me. Some of it's wrong, so you should fix it. Okay, so OpenStreetMap, or OSM, it's a free, open, and editable map of the world. So it's free in cost, and it's Libre. It's open and free to use however you want for commercial purposes or anything. It's editable by anyone. You don't have to have any qualifications or anything, and it's really based around people editing geography that they know locally. So it's a global map, but it's built by locals. And yeah, it's the entire world. It's everything that is mappable on the ground. You have to be able to see it. With 98% of it, you have to be able to see. So the usual OSM map that you know of is OpenStreetMap.org, and that's this color at the top here. The data behind it is the more important thing. The table at the bottom here is an example of the data behind the rendering above. It's got a lot of data in it, and each feature in the map has a lot of metadata. At the moment, it's about 7 billion nodes across the world. They get deleted and added. They get added at about 4.5 million nodes a day, and deleted at some rate that I couldn't figure out. The attribute table for OpenStreetMap is 83,000 columns wide. So that sounds appalling. It's obviously not a single table. There's no database that. Well, you probably could do it, but don't try. It's a key value store, so there's 83,000 rows in the table that holds the attributes. You can download the entire data set. It's about 100 gigabytes compressed, uncompresses to about 1.5 terabytes of a custom XML format called OpenStreetMap XML. That XML defines the structure, and that structure has come around from the history of OSM, which is based around collaborative, sort of low, non-technical users, and crucially, a system of recording history of every edit. So one of the primary things was we want a wiki map of the world. The crucial thing about wikis is that you can look at the history, and so one of the defining characteristics of this data set is that it tracks history. And from that came a slightly strange way of storing the geographic data. Basically, there's nodes. Those nodes can be connected with ways or lines. If you make a loop of a way, that becomes a polygon. And you have relations, which are groups of nodes or ways. And that's pretty much it. So there's no layers. Everything happens in a single two-dimensional space. Everything's smashed in together. If you have multi-level data, it's right on top of each other in the data set. You'll have nodes that could conceivably be right on top of each other. They're only separated by their attributes. So attributes or tags, so in OSM nomenclature, a tag is a attribute value pair. You can have attributes on nodes or ways or relations, and relations can also contain other relations. So that's pretty much all there is at the sort of the ground level, and in that there's a whole bunch of complexity, because anyone who is editing the map at any point can add any attribute they want with any value they want. We come to some agreements around what attributes we want and what values they should accept, but that's not built into the data model. And the other thing to note is that the data model is routable. This diagram is where we are today, and you can see the green is the footpath, and there's traffic lights up there, and it's incomplete. So it's not yet a fully routable network. I'll fix that soon. So the crucial thing about this sort of enormous data set of a fairly simple data model is that the ontology that you build into it becomes really important, because that's the only thing that allows you to say, okay, I want to work with building outlines or lakes or footpaths or mountain bike tracks or ski runs or whatever data you're actually looking at, you're only going to get at that data based on the attributes that are stored on it. So anyone can create it, and you create a new attribute simply by typing its name in and hitting upload. There isn't a sort of storage system of, I want to create a new attribute, that's a separate data item. It's not like that. There's a site called taginfo.osm, and that exposes all of the attributes that have been made, and so that's where that 73,000 figure comes from, is you can look at that and you can drill into each of them and you can drill into the statistics around different attributes. And when a certain number of people agree on certain attributes, the wiki will then be used to document, like, building equals yes, like the attribute building with a value of yes, Y-E-S in English, has become the standard way of recording a building footprint. So you'll draw a little rectangle and you'll have building equals yes, and then in the wiki there's a single page for that building equals yes tag and value, and it'll explain, there'll be pictures, there'll be suggested symbology, any other information about it. In tag info, you can see statistically common combinations of tags, and those will then get used in various editing software to produce what are called presets. So if you're adding a building in the ID editor, which is the standard web editor for OSM, it'll give you a list of building and street address and street name and suburb and things like that. And they're based around what have become common and then what have been declared to be good things to have together. It's all pretty democratic and community-based, so if particular regions, geographic areas or communities of interest have different requirements, they can just make them up. They can define them, they can write to them, they can agree on them, and they can start using them. And so different countries will have slight variations, but generally we sort of the basic stuff we try and keep the same. When you're editing the map, and you can add anything you want, often you'll edit something, you'll hit save, you'll go back to osm.org and you'll look at the standard render there, and it will look, the thing you've added will hopefully appear there if it's been set up in the standard cartography of that website. So that's just one single render, but it's the most popular, like it's the most obvious output of the project. And so people will sometimes try and make in south of Perth a while ago, we had a BMX track, and someone wanted that to look a bit more prominent on the map, so they turned it into a motorway, which makes it look nice and purple, but it's we don't really want to do that, because then the data is wrong. So the data is the primary thing here. The data should be right, and if the cartography is wrong, we fix the cartography. Internationalization and localization is a big part of it. For instance, the name attribute, if name without any colon and language code is always in the local language of wherever the feature is. Obviously, in some parts of the world, that can be a contested point, like what is the primary language of a large amount of the world. And so there's scope for disagreements and edit wars and all sorts of problems. But basically it should be the local name. Other names then also get recorded, and they're separate attributes. So here we've got Dhaka, and the English name gets recorded as name : en. And this thing of having an attribute with a colon in it, or multiple colons as a sort of namespacing system, is quite common for a bunch of different things. When you've defined the data, all of the attributes you can think of, whether or not they're rendered, there's a bunch of different ways of getting at the data set. So a common sort of first entry point is using web-based Slippy map tiles. They get served up by the osm.org servers. Those are available for use for community purposes. If you hammer them too hard with a commercial service, you'll get blocked. Generally that's, play nice is the rule. So there's a bunch of companies that produce different cartography and tiles that are available. And they also produce different export formats, GeoJSON shapefiles. A lot of the difficulty in producing those formats is in choosing how you translate the OSM data model into whatever the target data model is for for a shapefile, you've got to figure out how you want to split it up into points, lines, and polygons. It's generally topic by topic. You can't really get a sort of all of OSM in one export with no thought to how you're going to be using it. That you can do it, but it's generally going to be suboptimal. It's better to think of, oh, okay, I'm looking for parks boundaries in suburbia. So I want a certain thing, and I want trees, and I want footpaths, or like it requires a bit of thought and a bit of translation of that vast attribute space into whatever you're trying to build. So the other part that comes into that is there's two main APIs for actually querying the data set and only extracting some parts of what you want. The first one, the older one that's been around for quite a long time, is Overpass Turbo. I don't really know where it got its name, but it's the OSM API basically. It's a custom query language called Overpass Query Language, and with that you can query the attribute, the key value space, and you can extract a whole bunch of stuff and its geography. The other part of it is SOFOX, which is the newer version, and it's Sparkle. And if anyone knows what Sparkle is, it's super powerful, and it can be connected to other data sets. It's somewhat resource limited at the moment, so quite a lot of the queries you hit on that service will fail. There's a bunch of tools for downloading the entire data set to your own machines and keeping it up to date to the minute. I'm not going to go into those. Editing the data, there's a whole bunch of different systems for editing the data. ID up here is the standard one. When you go to the osm.org and you hit edit, that's what you get. Vespucci is a really good mobile editor for Android. JOSM is the standard sort of desktop application for most editing purposes. Field Papers lets you print it onto paper, and the Tasking Manager is really popular for dividing up digitization for crowdsourcing. And crowdsourcing is a big part of this. So the community at the moment is about 16,000 active mappers. That's mappers who have mapped at least once in the last 7 days. The OSM Foundation runs all of the servers and coordinates all the global fundraising and payment of the, I think, 2 full-time equivalent staff, which is spread around 5 people, I think. It's a pretty shoestring operation. All of the sysadmins are volunteers. There's a lot of volunteers involved. OSGeo Oceania is the Australian and regional chapter. The Australian mailing list is the most active place for Australians to get involved in the local community. And there's a bunch of Slack and Discord and Telegram and other avenues. And that's about it.